Hello and welcome to a tutorial on how to do a simulation in Google Spreadsheet. Now Google Spreadsheet is modeled off of Microsoft's Excel, so there's a lot in common between these two programs, and if you have Excel, most of this is going to be the same. So what I want to do here is I want to set up a simulation that will approximate for us the probability of rolling a 5 when you're rolling two 6-sided dice. Okay, so I have a couple of columns labeled out here. First off, I have my roll number that just tracks that's just going to track the number of rolls that we have so far. So let's go ahead and initialize that as a 1. And then in order to update that, we're going to use an equation. And to use an equation here, we need to start it out with an equal sign. So equals, we want to add 1 to whatever we had previously. So it's equals, click on the cell above this, and then type in +1. Now, the neat thing about Excel and spreadsheets here is that when you copy and paste this down to the next cell, it automatically updates that reference. So when I have this in A6, it takes this to mean as the cell above it, not as the original cell that I typed in. Okay, let's go ahead and get rid of these because we don't need them. To simulate a 6-sided die, we need a spreadsheet to choose a random number from 1 to 6 for us. Okay, so again, this is going to be an equation, so start it with the equal sign. We're looking for the command rand between. Okay, and as you type this up, you can see a nice little tooltip that's going to help you out with the syntax. We want our low number to be 1, comma, and our high number to be 6. Same thing for the second die. Equals, rand between, you can push enter to have that fill that in for you, 1, comma 6. Excellent, so now we have 2 die rolls there. We rolled a 1 on the first die and a 3 on the second. The next thing that we want Spreadsheet to do is add these together. So guess what? Another equation. Equals sum is the function that we want here. We want a value. Our first value is going to be B2, so you can either type in B2 or click on it. And then we want our second value to be C2. So press comma and then go ahead and click on C2, close your parentheses, and push enter. You can see that it's working. Our random numbers updated automatically, so we get 5 plus 2 is equal to 7. We can update them again. We get 3 plus 1 is equal to 4. Fantastic. Next, we want to add a check to check to see if the sum is 5. That way, we can add up all the numbers that we are going to get in this E column to get the total number of 5s that we've rolled out of a large number of trials. So we're going to go ahead and have here equals if is the command that we want. If our sum is equal to 5, so there's our logical expression, comma. If it is a 5, we want this to be equal to a 1. If it's not a 5, we want it to be equal to 0. Okay, so you can see here our sum right now is a 6. That's not a 5. So our relative our response here to is it 5 is 0, which is a no. Whoops. Let's update that until we get a 5 just to make sure that it's working. There we go. 2 plus 3 is 5, and it shows that it is a 5. Outstanding. Now this relative frequency here, let's go ahead and copy this down here. And so we get 2 rows of this. Right now, out of 2 trials, this is showing our relative frequency of 5 is 0%. We've had 2 trials, we've had 0 5s come out of those 2 trials. That means that we have a relative frequency of 0% of rolling 5s. Okay? If we continue updating this until we get 5, there we go, we got a 5 on our first roll. Just judging from this first row here, our relative frequency of a 5 should be 100%. Okay, we've rolled the dice one time, and it was a 5, so therefore we have a 100% rate of getting a 5. Now, when we take into account the second roll as well, now we have 2 rolls, and only one of them was a 5. That means that our relative frequency rate should be 50%. We had 1 success out of 2 trials. So in order to get this relative frequency to work correctly, here's what we need to do. We need to say that this is equal to the sum of all the 5s so far. We need to count up all the 5s that we've gotten. So in order to do that, remember when you copy and paste a formula like this, all of the, remember over here, whoops, let's just get out of this. Remember over here, when we copied and pasted this down, the A2 that was being referenced in this formula changed to an A3. So we want the starting point, we always want to start counting at E2. Okay? So that starting point should stay the same. In order to make it stay the same, we put dollar signs in front of whatever we want to stay the same. So $E, $2, and that will stay the same. And then in this first column, the first row, we want it to stop counting at E2. Okay? And we don't put dollar signs in front of that second one because we want that in the next row, we want it to start counting at E2 and stop counting at E3. Okay? So that will give us the total number of 5s that we have so far. And then we're going to divide by the roll number. Okay, and we do want that to move as well in the next one. Looks like I'm missing open parentheses. We can just delete that. So now when we copy that down to our third, whoops. There we go. Now we have a 5 in the first sum and a 4 in the second sum. So our relative frequency pattern matches exactly what we wanted to. Okay, we have a 100% after the first trial and a 50% after the second. All we need to do here is highlight the second row. Make sure that you highlight the second row and not the first one, because the second row doesn't have a formula in this first one. And then we can highlight all of our cells and paste that down. And you can see that as time goes on, we're getting more and more trials. There's our first 5 after the 8th roll. And our relative frequency is 0.125, 1 in 8. After our 999th roll, our relative frequency is about 8%. So let's go ahead and get a nice little chart of this. Let's highlight our F column and create a chart here. We want a line chart. And axis titles, we can put in axis titles if we want to. On our x-axis here, this is just trial number. But you can see there's a lot of variation at the beginning of this graph in the relative frequency. We start at 0% for a long time, and then it jumps up, goes back down, jumps up, goes back down, and then you can see that it starts to stabilize, right? Let's get a new set of random numbers here, and we get a new graph. Here, we actually rolled a 5 on the first trial, so we started at 1%, and then it goes down, it goes up a little bit, but it stabilizes. See, the last graph stabilized at about 8%, this one stabilized at about 12%. But you can see that it's getting relatively stable. Let's go ahead and update this again. We started at, wow, we had a lot of zeros all the way up until our 32nd trial. But you can see that this is getting more and more stable as we are increasing our sample size. This one stabilized at about 11%. Now, probabilities will always stabilize at some constant given a large enough sample size. And you can see our from our three basically quote-unquote final relative frequencies, because those threes were so different, we got 12%, 8%, and 11%. 1,000 trials, we don't quite have 1,000, but we almost have 1,000. 1,000 trials is not really a large sample size. We need something in the tens of thousands in order to really get this to stabilize in a consistent manner. But that's how you do a simulation. You can keep updating these. I'm just pressing the backspace key in an empty cell, and it keeps updating. Ooh, I think we did well here. Yeah, 13.5%. But you can, the important part of this simulation here is that we get this stabilizing effect as our sample size gets larger and larger. And if we added 1,000 more rows to the bottom here, and let's get up here, copy, and paste that down. Now we have almost 2,000 trials, and you can see it looks like it's getting even more stable than it was before. There's about our 1,000 trial number, and it's much more stable after that. Let's try it again. It'll take a moment here. You can see there's our 1,000. It's much more stable after the 1,000 than it was before the 1,000, and that will continue as your sample size gets bigger and bigger. So go ahead and give this a try for yourself. Try it out with 7. There's really only one column that needs to be changed, and it's this one right here. Instead of checking to see if it's 5, you check to see if it's 7. Go ahead and try this out for yourself. I think you'll have a lot of fun with it. Bye-bye now.